morning guys, so welcome again to my video and for this video I will going to summarize this chapter. So let's start. Chapter 9, Transport Layer. The transport layer provides transport related services by dividing data received from an application into segments, adding a header to identify and manage each segment, using the header information to reassemble the segment back into application data. UDP and TCP are common transport layer protocol. UDP datagrams and TCP segments have header added in the front of the data that include a source port number, destination port number. These port numbers enable data to directly to the correct application running on destination computer. TCP does not pass any data to network until it knows that the destination is ready to receive it. TCP manage the flow of the data and resend any data segment that are not acknowledged as being received at the destination. TCP use mechanism and handshaking timers, acknowledgement messages, and dynamic windowing to achieve reliability. The reliability process, however, imposes an overhead on the network in terms of much larger segment headers and more network traffic between the source and destination. If the application data needs to be delivered across the network quickly, or if the network bandwidth cannot support the overhead of control messages being exchanged between the source and the destination system, UDP would be the developer preferred transport layer protocol. UDP provides none of the TCP reliability features. However, this does not necessarily mean that communication itself is unreliable. There are many mechanisms and application layer protocols and services that process lost or delayed datagrams if the application has this requirement. The application developer decided the transport layer protocol that best meets the requirements for the application. It is important to remember that the other layers all play a part in data network communication and influence its performance. Data network and the internet support the human network by supplying reliable communication between people. On a single device, people can use multiple applications and services such as email, the web, and the instant message to send message or retrieve information. Data from each of these applications is packaged, transported, and delivered to the appropriate application on the destination device. The process of describing in the OSI transport layer accept data from application layer prefer it from addressing at the network layer. A source computer communicates with receiving computer to decide how to break up data into segments, how to make sure none of the segments get lost, and how to verify all the segments arrive. When thinking about the transport layer, think of the shipping department preparing a single order to multiple packages for delivery. So TCP provides tracking and transmitted data segment. Destination devices will be acknowledged using data. Source device will be retransmit unacknowledged data. UDP destination device will not acknowledge received data, and headers are used very little overhead and cause minimal delay. What happens if part of FTP message is not delivered to destination? The part of PTP message that was lost is resent. Because FTP uses TCP and its transport layer protocol sequence and acknowledgement number will identify missing segment which will be resent to complete the message. Multiplexing is useful for interleaving multiple communication streams. Window size is used to slow down the rate of data communication. Ports numbers are used to pass data stream to their proper application. Acknowledgement are used to notify a sending device that our stream of data packets has not been received. Registered port number 1024 to 49151 are assigned by AINA to requesting identity to use with the specific processes or application. These processes are primarily individual applications that user has chosen to install, rather than common application that would be received as known port number. A socket is combination of source IP address and source port or destination IP address and destination port number. There are three ranges of TCP and UDP port. The well-known range of port is from 0 to 1020. In TCP session, when device has no more data to send, it will send a segment with a pin flag set. The connected device that receive the segment will respond with an ACK to acknowledge its segment. The device that sent the ACK will send a pin message to excuse me, close the connection it has with the other device. The sending of pin should be followed with the receipt of ACK from the other device. Oh. Each application process running on the server is configured to use a port number, either by default or manually. By a system administrator, an individual server cannot have two services assigned to the same port number within the same transport layer services. A host running a web server application and file transfer application cannot be both configured to use the same server port. There can be more ports open simultaneously on the server, one from each active server application. TCP used the CUYN and ACK plugs in order to establish connectivity between two network devices. With a window of 1,000 bytes, the destination host accepts segment until all 1,000 bytes of data have been received, then destination host sends an acknowledgement. Window in the number of bits that our sender will send prior to expecting an acknowledgement from the destination device. The initialized window are agreed open during the session startup via the three-way handshake between source and destination. It is determined by the how data destination device and TCP session is able to accept and process at one time. At the transport layer, TCP uses the sequence numbers in the header of each TCP segment to reassemble the segment into the correct order. If the source determines the TCP segment are either not being acknowledged or not acknowledged in a timely manner, then it can reduce the number of bits it sent before receiving acknowledgement. Notice that it is source that is reducing the number of acknowledged bits it sent. This does not involve changing the window size in segment header. UDP has no way to reorder the datagrams into their transmission order, so UDP simply reassembles the data in the order it was received and forwarded it to the application. So thank you guys for watching. I hope you like this video and see you again in my next vlog. Bye bye!